Hello, and thank you for joining this session on inspection lifecycle and process design. My name is John Shaboshnig, and I will be your moderator for the live Q&A session today. Before we begin, I'd like to thank our two speakers, Roy Cherris from Bridge Associates International and Julie Menke from Pfizer, for preparing excellent presentations today. With that, let's get into your questions. Roy, what we're really asking is about the apparent disconnect between acceptance criteria for critical defects for 100% versus what is often seen in NAP studies where values less than 100% are seen. What do you think is appropriate in terms of setting acceptance criteria for inspector qualification or AVI qualification?
Well, first of all, you have to decide how many critical defects can I include in that test set. So, from a statistical standpoint, I can't have a million defects in there that are critical. I have to have a limited number. So that would make it difficult for me to actually get a percentage much lower than 100%. Realistically, we can try and shoot for 95% and greater, but that would require a significant number of critical defects to get that number on a regular basis during qualification.
Thank you. Julie, I'm going to put this question to you, and this is a more general question than the detail that you provided with regard to bracketing, but I think it's still an important question. And the question is it a regulatory expectation that as you move from manual to semi-automated to automated inspection, you must demonstrate equivalency or better to that manual human baseline?
Yep, so it is an expectation that we would compare everything back to our manual baseline before moving to either semi-automated or automated manual or automated inspection.
Thank you, Julie. And Roy, go ahead and jump in.
My 2 cents would be that the general expectation from regulators, and I think our own expectations in the industry based on 790 and 1790, would be that it has to be equivalent or better in these alternate inspection methods.
And Roy, I'll ask this one of you. So if you're doing an AQL inspection, is it expected that you investigate when 1 or 2 particles are found during that AQL inspection, and then they go on even for intrinsic or inherent particle types?
Well, I think you have to look at it this way. When you've gone through your 100% inspection, it's a cleansing process. You've removed all the defects in an effective way. And then you go to the AQL to be to judge how well you did. One thing we know when it comes to particulate matter, we're going to have a problem that I have affectionately coined the phrase NAP gap. The NAP gap is that we are going to miss particles. And so it is very important for you, even if you're within your AQL levels, for you to go back and take a look and identify those particles in the AQL stage. These are particles that are coming from the good fraction of product. And if they're in the good fraction of product, which you are planning to market, it is incumbent upon your organization to know what types of particles could be resident in that good fraction. And so it is a very good idea to use those metrics and follow the particles so you know what is actually a routine occurrence versus something that might be abnormal.
If I can just add that,
yeah, go ahead.
I think this is where the trending program really comes into play for visual inspection. Watching those trends either on a weekly or monthly basis, if you see some special cause variation in either the amount of particles found during inspection or during AQL, that should be your indicator to investigate.
Excellent, excellent. Julie, this is really going into a bit more detail with some of the work that you described. And this person is asking, are you controlling for other physical properties such as refractive index, product stability, and or particle stability in product solution?
I'm sorry, can you ask that again?
Sure. It's really, and I think it's with regard to your qualification strategy. Are you controlling for other physical properties such as refractive index, product stability, and/or particle stability in the product solution?
So I didn't take any of those into account when creating the bracketing strategy, but those would be one-offs that if your strategy determined to select a product that maybe doesn't have stability, you obviously could not select it for the bracketing strategy. And that's where that risk assessment really needs to come into play. If theoretically you're determined that you should use that in your strategy, but due to the nature of the product, you can't, you need to include that as a risk assessment and what is the risk of not including it or not testing to it.
Thank you. And this, I'll kind of open up to both of you, but I'll ask Roy first. And this is looking for some general recommendations when you have a new product. How do you set alert limits for critical, major, and minor defects?
Okay, so when you have a new product, if it's your only product, then it becomes a little bit difficult. Generally looking for industry standards, what other companies are doing is really the best practice, but you need to create a model. And the model would be, if you have any other products that are similar in all, these would be a good starting point for your expectations for producing the new product.
And Julie, can you add your thoughts to that?
Yep, I agree. I think looking at your product portfolio, if you have something similar or even something that runs on a similar line or a similar inspection type, I think those would be things that you should consider when looking at what initial limits to set. And then I think that a reevaluation of those limits needs to be performed after 30 batches.
Absolutely. That's really key. Very good statement there, Julie. You really need to look at this over a period of time. So we're really not going to get really stable information, information that we can rely on as a limit until we get out over 30 batches. So we need to look at this at periods, after 5 batches, 10 batches, 20 batches, and then finally to the point where we have a reliable action level.
And again, I'll ask this to both of you, but Julie first. This is really talking about trending data from automated inspection equipment. And they're asking, is it acceptable to look at a sample of those that have been rejected and inspect those manually for trending purposes rather than examining every unit? Their example is, could I look at 20% of those that are rejected and characterize those for trending rather than doing every unit that is rejected by the AVI system?
Well, the ultimate answer to that would be, you really should do a period of full reject characterization for a period of time to get the full example of the background populations of particles or defects that are there. And then, just like with any other quality assurance process, you rationalize how you can back off and do fractional testing. And that fractional testing should and can be done by statistical calculations, like the square root of n+1 is one that is universal to all, and you can select a fraction of your defects to monitor and trend on a regular basis. So the work should be put up front to develop a good baseline and understand the full defect profile, and then later with the intent to back off and do it at a more reasonable approach.
Just to add on to that, when you do that statistical analysis, you need to make sure that you are sampling a large enough representative sample to capture the minute defects that you might find. So usually your critical defects have your lowest percentages. You want to be sure that that sampling plan would still be able to adequately capture that low of a defect percentage. And I think moving forward, once that is implemented, there needs to be some type of a regular basis where 100% of those rejects are classified, maybe 10% of the time or so when limits are exceeded, annual stability lots, those type of things.
I'll ask this next question to Roy, since you were involved with writing PDA Technical Report 79, which was for difficult to inspect products. This is with regard to a cell therapy product that requires that it be frozen shortly after filling. So the question is, how do you handle AQL inspection when you have to freeze something shortly after it is filled, and obviously then shortly after it has gone through that 100% visual inspection?
Well, I think, we need to first decide, we're not going to, if the unit is sealed prior to that freezing, at that point is your opportunity to do your inspection. So the AQL process can be an in-process inspection immediately before going to that freezing process, and that's really your only opportunity to get it in a state that facilitates the whole process before the freezing process. Other than that, you would have to go to a destructive testing regime, which obviously will reduce your overall yield. So really highly advised trying to do it before freezing.
Let me just ask, and I'm going to ask this of you, Julie, but I realize it may be outside of your experience, but it really is talking about eye exams and whether you can do those in-house with your own people versus whether it has to be done by a licensed optometrist or an optician. What's your experience there, and maybe what's your recommendation?
Yep. So I think if the site has a health center there, then I think it should be done on site. It would be easiest that way rather than sending them off site. But I do think it needs to be done by a licensed physician or nurse.
And Roy, I think this one is right in your court. It says for product lifecycle transparency, are there software programs or technological tools that are recommended to accurately track or serve as a repository for this kind of information?
Well, right now, I guess I'm going to have to be selfish and tell you about the offering from InQuest Science. InQuest Science has been actively working on the lifecycle management process for visual inspection that goes from cradle to grave. So in other words, the infographic that was in my presentation would be the similar approach or a modular approach that InQuest Science has taken to develop database modules around each one of those areas of concern to fill in the gaps, and they're integrated. So I would tell you to look at the InQuest offering. There are other types of databases out there. You have your limb systems and things like that, but we talked about some of the limitation of these individual systems. They don't have the expert programming and the ability to do all the things you'd like it to do without some expensive additional programming, like in the SAP system or all the other limb systems that would have to be specially programmed. Other than that, you can use Excel spreadsheets, but of course, they have their own issues with Part 11 compliance.
Julie, any tools that you use that you would find helpful? I know you are involved with working with a fairly large network of aseptic sites where various inspection programs are in place. Any tools that you find helpful in that regard?
Yeah, I've used everything from Excel spreadsheets to locally developed programs to programs that were purchased and optimized for our network.
Let's, and Roy, kind of getting back to difficult to inspect products here. This is a question with regard to LIO inspection, inspecting the LIO cake. From your experience, what do you think is worst case? A 1 mil fill of a LIO cake in a vial with a wide base, or a 1 mil fill in a vial with a narrow base? So are we talking about a sort of a wide flat cake or a tall skinny cake? Which do you think would be more difficult to inspect?
I think that they would be roughly equal. The wider cake obviously gives you more top surface area and bottom surface area to inspect. The taller, narrower cake allows you to really look at the body of the cake or the wall of the cake. Without having to do surface area calculations, I would say the one that gives you the most surface area to examine in an inspection probably would be the best, because we're not seeing in the cake. We are seeing gross particulate matter on the external surfaces of that cake. And, if we're really lucky, maybe slightly into the cake, you might see something dark, a mass or something like that. But realistically, it's based on surface area.
And I think you made a good point there, Roy. No matter what, either of those configurations would be a difficult to inspect product and require supplemental testing because you can't see inside the cake. So you're going to have to do some limited destructive testing just to detect that gross failure with regard to particulate matter.
Yeah, and in addition to that, you really have to be on your game with the upstream life cycle controls, obviously, because you're dealing with something you can't fully inspect at the endpoint.
All right. Let me just scan through the questions one more time here and see what has popped to the top of the list. There is a question here with regard to the qualification trials that are done for initial qualification. And that is, should those qualification trials, it says, be done independently, or should they be done supervised by a qualified inspector? So maybe a more general question in terms of how do you manage the qualification of a new inspector, and what does that qualification test look like? And Julie, maybe I'll ask you first, but then I'll ask Roy to add his comments as well.
So a training specialist or an inspection trainer should be present during the qualification, and they should be monitoring the performance of the individual during the qualification, making sure that they're adequately performing the procedure and doing it within an adequate pace.
I totally agree with that statement. It's beneficial to have a proctor there who is evaluating the person's performance from a side view. But essentially, the monitoring, if the entire test set is blinded and the person is following the pacing, we may not have to watch them actually during this process. Because the system is blinded. So their response, if they're not using the appropriate techniques, chances are they would not get the appropriate responses for the appropriate rejects, and have maybe a false reject rate that's not within expectations.
Great. Well, I'm going to bring our Q&A session to a close here. I certainly want to thank, again, both Roy and Julie for responding to questions that were directly related to their presentations, as well as going a little bit more broadly afield here. I think your answers have been very helpful for our audience here and their understanding of the visual inspection process, and really establishing a robust visual inspection program. So my thanks to you both. I want to remind our audience here that please join the virtual exhibit hall that remains open, and connect with our conference supporters. We will have a session at the end for further discussion on these topics, so you can network with other participants and the speakers. And I do want to remind you that the next session that follows will be our closing plenary session. We will have a summary of the meeting, so hopefully help you put together your virtual trip report. And we will have an open Q&A discussion, a large panel of experts in the area of visual inspection to hopefully answer your questions then. So again, thank you for your participation in this session, and look forward to interacting with you with the panel that is coming up. Thank you. And that'll close this session.